So students, our today's topic is vertical circular motion, right? So let's start vertical circular motion. So for vertical circular motion, let an object of mass m performing the vertical circular motion, and here it is the radius of the circle, capital R, or you can say you can take a smaller anyone. So this is the center of this circle. Here the top position of the object, this one is the bottom point and this one is the midpoint, right? A, B and C. Okay, so A is the top point, B is the bottom point and C is the midpoint. Now if M is the mass of the object and V1 is the velocity at point A, V2 is the velocity at point B and V3 is the velocity at point C. You can take VA, VB and VC also. Okay, so V1, or you can say VA here, VA, VB and VC, right? These are the velocities at the different point. If T1 is the tension in the upper part of the string and T2 is the tension at the lower part of the string, so I can write T1, T2. Both the tension are towards the center, right? And mg here at mg will act downward. Here also mg will act downward, the weight of the object. Clear? Now see here at point A, first I will write at point A. At point A, the necessary centripetal force for the object to continue its motion on a vertical circular track at point A, it will be provided by these forces T1 and mg. So I can write T1 plus mg at point A, T1 plus mg equal to mva square upon r, right? Now tell me, if the tension in the string will become zero, then it will means it will not continue on the vertical track. Okay, vertical circular track. So if condition is if T1 equal to 0, then it will be mg equal to m. This is the condition, mva square upon r. M and m get cancelled. So VA square equal to G into R, GR. So VA equal to root under GR. This is the minimum velocity required to the particle at point A, this point, to continue its motion in the circular track. Okay, this is the minimum velocity. Now at point B, see at point B, we can apply energy conservation law. So what energy conservation law says? That the energy will be conserved, energy cannot be created and cannot be destroyed, only can transform from one form to another form. So see here, at point A, the energy at point A, total energy at point A must be equal to total energy at point B. So at point B, by energy conservation law, total energy at A must be equal to total energy at B. So what is the total energy at A? Kinetic energy at A plus potential energy at A. That will be equal to kinetic energy at B plus potential energy at B. Okay. Now see here, what is kinetic energy at A? It is half mva square plus what is potential energy? If it is the surface means the height. We measure height from this point. So what is the height? This is the radius, this is the radius, or you can say the diameter. Okay, 2r. So mg into 2r. So 2 mgr. This will be the potential energy at point A. Now tell me, what is the kinetic energy at B? Half mvb square, and the potential energy at B will be equal to 0. Okay, so now what I will do, I will shift this half mv square to the right side, and I can write it half mvb square minus half mva square equal to 2mgr. I can write it like this. Okay. Now take 1 by 2 m common, and it will be Vb square minus Va square, that is 2mgr. Shift this 2 and cancel the m. So Vb square minus Va square equal to 4gr. Now see here, what is Va? Va is root under gr. Then the square of root under gr will be Vb square minus the square of root under gr. It will be gr equal to 4gr. So it is Vb square equal to gr will add with 4gr, and it will be 5gr. So Vb equal to root under 5gr. This is the minimum velocity required to the object at point B to continue its motion on this vertical circular track. Similarly, we can find the velocity at the midpoint C. So again, we can apply energy conservation law. So by energy conservation law, by energy conservation law, by energy conservation law, total energy at B must be equal to total energy at C. Now what is total energy at B? Kinetic energy at B plus potential energy at B equal to kinetic energy at C plus potential energy at C. Okay. Now see here, what is kinetic energy at B? That is half mvb square plus potential energy at B is equal to 0. Kinetic energy at C is half mvc square. And what is the potential energy at C? It is mg, and the height is r. So mgr. Now I can write it, shift half mvc square to the left side, half mvc square equal to mgr. Now take half m common, it is vb square minus vc square equal to mgr. Cancel m and m, shift 2 there. So vb square minus vc square equal to 2gr. Now what is vb? Root under 5gr. Put here. Root under 5gr square means it is 5gr minus vc square 2gr. So minus vc square, or you can directly write vc square equal to 3gr. So vc equal to root under 3gr. This is the minimum velocity at point C required to the object to continue its motion on vertical circular track. So these are the minimum velocities at top point, at bottom point, at midpoint for vertical circular motion. Okay, so note it down.